Welcome to ClickMyProject.com. The title of the project is a novel classification framework using the graph representation of electroencephalogram for motor imagery based brain-computer interface. And the abstract of the project is the development of an electroencephalograph based brain-computer interface requires rapid and reliable discriminations of EEG patterns. Example associated with imagery movement. Brain-computer interface provides an additional communication channel for individuals with communication disabilities. In general, motor imagery-based brain-computer interfaces need to be trained offline for a considerable period of time, which causes user to become fatigued. This reduces the efficiency and performances of the system. The start of the queue is often used to initiate the feature window used to control motor imagery-based brain-computer interface systems. However, the time latency during an motor imagery period varies between trials for each participant. Fixing the starting time point of motor imagery features can lead to decreased system performance in motor imagery-based brain-computer interface systems. We propose a machine learning algorithm to efficiently analyze the motor imagery-based brain-computer interface by using electroencephalograph. The extra-T classifier and random forest classifiers are implemented and analyze the motor imagery EEG data and detects the right hand, left hand, both feet and tongue classes. Then it generates the results in terms of matrices like accuracy, precision, recall and FN score. And the flow diagram of the project is first we need to start the program and select the data set as motor imagery encephalogram dataset. Then we use the sample dataset in our console working directory. After that, it will apply into data pre-processing. In data pre-processing, we are going to check the missing values and null values that contains from our dataset. Then after cleaning, it will apply into classification. In classification, we are using two different types of machine learning algorithms like extra-T classifier and random forest classifier. The both classifier will use it to classify the motor imagery encephalogram dataset and generate the result in terms of accuracy, precision, recall and FN score. The program was successfully executed in Anaconda Navigator Spider IDE, and these are the result of the classification of motor imagery EEG signals. So in here we are going to classify the right hand, left hand, both feet and also tongue. So this is our first module, data selection and loading module. In here we are going to read our input dataset. Our dataset contains train data and also text data. It's separated as X-train, X-test and Y-train and Y-test dataset. So this is the sample visualization of X-train data and this is the sample visualization of X-test data and this is the sample visualization of Y-train and this is the sample visualization of Y-test data. So after that I have to check the information about the X-train dataset and X-test dataset. So in here it contains 640 columns, so all the columns are considered as the float 64 data types. So after that I have to check the description about the X-train dataset and also X-test dataset. So in here we are going to find the count value, mean value, standard value, minimum value to maximum value for every columns contains in our dataset. So after that I have to, it will apply into data pre-processing. This is our second module. So in here I am going to check the missing values that contains from our X-train and X-test dataset. So there is no missing values contains in our X-train dataset and also X-test dataset. So after that I have to visualize the number of count values that contains in our Y-train and Y-test dataset. So Y-train dataset contains overall 6000 data that contains from the every classes, and test data contains more than 600 data that contains from the every classes. So this is the pie chart of the count plot. So this is the train data pie chart and this is the test data pie chart, and these are the classes between 0 to 3. So after that it will update into classification. In classification we are using machine learning algorithm. So in machine learning we are using XRT classifier algorithm. So the XRT classifier algorithm will achieve the accuracy rate is 84%, and these are the classification report. So this is our proposed algorithm. The existing work which is achieves the accuracy rate is 80.20%. So now our proposed system achieves the accuracy rate is 84%, and these are all the classification report of our XRT classifier algorithm. So in here we are going to find the precision recall F1 score value for every classes like left hand, right hand, both feet and also tongue. So in here precision means number of correct prediction, recall means number of correct instance of prediction, and F1 score means to measure the test accuracy. So this is the confusion matrix diagram. The confusion matrix is it, and this is the confusion matrix diagram. The confusion matrix diagram which is going to explain the number of correct prediction and misclassification that attains from our XRT classifier algorithm. So our second algorithm is random forest algorithm. So the random forest algorithm attains accuracy rate is 80%. So it is similar to our existing work accuracy result. So these are the classification report of random forest algorithm, and this is the confusion matrix result for random forest algorithm, and this is the confusion matrix diagram. So the comparison between XRT classifier and random forest algorithm comparison results. So these are our variable results that we are used in our program.